Hi, hello everyone. Welcome back to our channel RL Lab. So we were discussing real numbers in this last episode, right? In the last video. So today we will try to continue the same exercise. So fourth problem, root 5 is irrational. We need to prove that root 5 is irrational. So how to prove? Same in the indirect method of proof we have to assume. First let us see the proof, how to write it. So first I am assuming this as, let root 5 be a rational number. Let root 5 be a rational number. Once it is a rational number, it should be in the form of p by q, right? Root 5 is equal to p by q, where p comma q belongs to integers and q is non-zero and co-primes. This is compulsory. They should be co-primes. P and q should be co-primes, right? Now do the cross multiplication. Q into root 5. Root 5 into q is equal to p. Now squaring on both sides, you try to make it squaring on both sides. Squaring on both sides. Root 5 into q whole square is equal to p square. Now this root 5 whole square into q square is equal to p square, which is nothing but here 5 is equal to 5q square is equal to p square. So what is this meaning? Here 5 is a factor of p square, q square is also a factor of p square. By known theorem already we have seen, if p divides a square, then p is also divides a, where p is prime number, a is a composite number, right? So here also 5 is a prime number. So clearly with that theorem 5 divides p square, then that implies 5 is also divides p. This is divisibility symbol, right? Name it as equation 2 and name this equation as 1. So as this is 5 divides p here, right? Means whenever 5 divides p, suppose here 4 divides 12, no? 4 divides 12, right? So means this 12 can be expressed as 4 into some other number, no? Isn't it? 4 into some other number. Let us say x or 1, here 4 into 3. So I am assuming 12 as 4 into x. Here I am assuming this p as 5 into something. Okay? So let us assume, let p is equal to 5r for some integer r. For some integer r. So I am assuming p is equal to 5r for some integer r. So from equation 1, if you substitute this p equal to 5r in equation 1, what do you get here? 5q square is equal to 5r. P square, no? 5r whole square means 25r square. Is nothing but 5 ones are 5 5s are. So q square is equal to 5r square. Again that implies 5 divides q square. Then that implies 5 is also divides q. From equations 2 and 3, what did you observe? It is crystal clear that equation 2 and 3, from equations 2 and 3, it is clear that 5 divides p and 5 is also dividing q. Means 5 is a common factor for both. 5 is common factor for both p and q. Apart from 1, they have common factor 5. But what is p and q here? P and q should be co-primes. When they are co-prime, they should not have any common factor other than 1. But here we got 5 is a common factor for both p and q. Why this has arisen? Because of our assumption. What is that? Root 5 is a rational number. So our assumption is wrong. Then what is right? Root 5 is rational only. Correct. Clear? So 5 is a common factor, but this contradicts the fact that P and Q are co-primes. P and Q are co-primes. So this has arisen because of our assumption. Because of our assumption. Okay. So therefore, what is right? Root 5 is rational, is wrong. Root 5 is rational, is wrong. Then what is right? Therefore, root 5 is irrational. Therefore, root 5 is irrational. Is it clear to everybody? In this way, for square root of any prime number, square root of any prime number can be proved in the same manner. Square root of any prime number can be proved in the same manner. I hope this is understood by everyone, right? So one more example is left, one more problem is left in this. Prove that root p plus root q is irrational. So far we have seen only with respect to the numbers, but here they have given variables. Here they have given variables. No problem. If it is variable or number, we have to follow same procedure. So I am assuming let root p plus root q be a rational. Same procedure, there is no change at all. Okay. Now once they are in the rational form, definitely they should be in the form of p by q, but already they have given that p and q in terms of p and q problem itself. So I am assuming a by b. Okay. Here they have given that p comma q are prime numbers. Remember this. P and q are primes. Let root p plus root q be a rational number. Root p plus root. So where here a comma b belongs to z and b non-zero, and a and b also co-primes. What is this? Co-primes. Clear? So now send one of the root p and root q to the RHS. Root p is equal to a by b minus root q. Again do squaring on both sides. Squaring on both sides. So what will you get? Root p whole square means you will get p. This is a square. A square by b square plus root q whole square means q. You will get only q. Next minus 2ab. 2ab by b into root q. Okay. Bring this term to the LHS and send this p to the RHS. So you will get 2a by b into root q is equal to a square by b square plus q minus p. Plus q minus p. Okay. Now take the LCM RHS side. B square. This is a square plus q minus p into b square now. If you take the LCM, you will get this. This is 2a by b into root q. Now root q if you write here, so it will be a square plus b square into q minus p by b square. If you send this 2ab to the RHS, that becomes b by 2a. Now 1b, this b gets cancelled, left over with root q is equal to a square plus b square into q minus p whole divided by 2ab you will get. Here 2a, here 1b will be left, 2ab, right? This is what you got the information or expression by using this. Now since same procedure, same steps I am writing. Are you observing? I hope you all are with me. Since p and q are integers, sorry, here not p and q, here a and b, right? A and b are integers. So what will becomes? A square plus b square into q minus p by 2ab is a rational. Once they are integer, this become rational. So once it is rational, then that root q should also becomes, root q is also a rational. But is it true? But this contradicts the fact that, what is that fact? Contradicts the fact that root q is irrational. Root q is irrational. Here you may ask that, sir, who said that, sir, root q is irrational? But q is, in the given problem itself, they have given that where p, q are prime numbers. Square root of a prime number is always irrational. Please be remember this. Square root of irrational number is always, square root of prime number is always irrational. Okay? So square root of q is a prime, square root of prime number is irrational. Since q is prime, that is why root of q is irrational. So this is contradiction. Why this contradiction has arisen? This has arisen because of our assumption, because of our wrong assumption. So because of our wrong assumption. So what is right then? Root p. Therefore we can conclude that root p plus root q is irrational. Root p plus root q is irrational. Clear? So whatever may be the question, whether it may be numbers or variables, the procedure is same. So this is about 1.4 exercise. I hope you all of you understood this. So if you like the video, please subscribe the channel and share and like it. Thank you for watching.